So this is 3.7 again, and it is modeling with a linear equation. And so let's take a look at example 4 in the book on 241. It says modeling worldwide HIV/AIDS cases in children. So it said in 2012 there were about 3.3 million children under the age of 15 living with HIV and AIDS. And so the rate of new infection was 0.26 million per year. So right away they've told us what we need to create our equation, because they want you to write an equation with C being the total number of children who have HIV equal to mx plus b. And so they told us the B right from the start, because they said total of 3.3 million children in 2012. So this told us our y-intercept. And then when we were told the 0.26 million per year, when you see two units like this, millions is the number of children per year, per is the division or the line, okay, and per year, year is what year it was occurring in, or that year, per year, 1 year. So that told us the slope right away. So that's why right away we could write our equation of c equal to 0.26x plus 3.3. And we're going to assume these numbers are already in millions, so we don't need to put in all the digit zeros for millions. We just know that when we get a number, that number gets translated into millions. It just makes it easier to write an equation without all those zeros in place. And then once we have that equation, we can estimate it. What was the number of children in 2015? Well, 2015 minus 2012 is only 3. So we're going to put 3 into the x, because that x represents the years. And so at 3 times 0.26, then add it to 3.3, gave us 4.08, and it's in millions of children. So this gives us an idea of how we do this in the real world as well. Take a look at example 5, where you're supposed to read something and then translate it into numerical setup. So a quantity y is initially 500, which is our y-intercept. It's increased at a rate of 6 per day. So there's our slope. So we would write y equal to 6x plus 500. Same thing here for B. A quantity y is initially 1800. There's our y-intercept, and it's decreasing, which means it's negative at a rate of 25 per day. So that would be negative 25x. And so that's why we have y equal to negative 25 plus 1800. And then a quantity is initially 18,000 and remains constant. So they're not telling us slope, which means it must be 0. And so that means it stays 10,000 all the time. So we're just writing y equal to 10,000. So these are the types of things you'll see in homework and quizzes and possible tests. So let's take a look at another problem before we close, which is problem 52 on page 244. Okay, so this one, problem 52, is different because when we plot these points, we're not going to get a very nice line at all. So that's what you have to do. You need to graph these points on a graph paper. Don't graph it starting at 0 to 40 to up to 80. I would start at around maybe 40 and go up to maybe 90 on the y. And then for the x, maybe put it at -2 to maybe 5, so that you plot all these points. Okay, so once you plot it, then you've got to draw a line of best fit. So draw your line of best fit. I did it on the calculator, which I'll show you later, but not today. But if you go on, here is my data points. So I have my first one at 0.80. I have my second one at 1,61. My second one was 42, and then the third one was 343. So notice when I tried to draw a line, it did not get a very good, it did not go through all the points. I have 2 above and 2 below. This is the best I could come up with. You might have drawn yours just slightly different. but you have to practice being able to draw a line of best fit. Now that I've done that, I can't pick these points. I could pick the points 1, but it's no longer going to be 61. So for example, if I go to second calc, I can pick value and type in 1, and it will tell me what that value is. It is 63. So I have 1 comma 63 that I'll write down. So I'll go down to, I'll close this and go to my paper. So this is my first point. Oops. So 1 comma 63, and then I'll pick 2. So I'll go to second calc and I'll type in a 2, and it'll tell me the y value is 50. So I'll go to 50, so 252, 2 comma 50. Okay, and so I can pick any points I want, just that I want to make sure that they're on the line. I can't pick the points that are just being slightly touched or not being used at all. Okay, so I have to pick new ones. So now I can use this to help me come up with an equation, because this is x1, y1, this is x2, and then y2. So my slope is 50 minus 63, and then 2 minus 1. So 50, that makes it negative 13 over 1. So here is my equation, my slope. Now I do the point piece, point slope. So I'll do y minus 50 equal to negative 13 times x minus 2. And so I get y minus 50 equal to negative 13x plus 26. So I add the 50 to both sides, and so now I get y equal negative 13x plus 76. So here is my equation. I'm expecting it to be negative because the line is going downward. Okay, and then it finally says, estimate the air temperature 5 miles high. Okay, so 5 miles high, so I'm going to go y equal to negative 13 times 5 plus 76. So y is, this is negative, so that makes it negative 65 plus 76. So y is, I just have to go negative 65 minus from the 76, so I get 1. Okay, and it's positive. Okay, and so that would be my degrees Fahrenheit at 5. Okay, so now let's go back to the book or my calculator and see what I got when I put 5 in. So I'll go to second calc, I'll put in 5, oopsie, and I get, let's go to second calc, I'll hit enter and put in 5, okay, and I get about 11. It's exactly what I came up with. Okay, so 11 is what's working. So this is relating back to that problem, okay, saying that gradually the air temperature becomes colder as the altitude above the ground increases. So the table lists the typical air temperatures. So predicting at 5 miles, then I'm looking at about 11. Okay, so this is another type of problem. But in this case, this problem, when we looked at the graph, your line is not on here. So it's a good example of showing you the type of problem that you could run into where your points that you plotted originally are not on your line. And you need to pick the points on your line. You cannot use the points that you see that are not on the line once you start to create your equation. And that's it.